Hello, I'm Jason Glazer, and welcome to another video on SPC 229 schema. Today we are covering data groups for FanSystem, AirEconomizer, and AirEnergyRecovery. As you probably remember, for the first week of this after the video is posted, we encourage discussion by email of any issues found. Hopefully all issues will be identified during that week, and after that we'll have a letter ballot, which will also be 1 week. If minor issues are raised during the discussion, that will be included in the letter ballot. If something is more major or complicated, then it'll be referred back to the schema working group. Today's video is the second of 3 videos covering airside of HVAC. Last time we started at the top with heating, ventilation, air conditioning, heating system, and cooling system. This time we are diving a little deeper into the air side with FanSystem and 2 of its children group, AirEconomizer and AirEnergyRecovery. While the water side HVAC and air side HVAC might be about the same level of complexity, the water side decomposes into an architecture that's relatively simple. The air side is not as simple to decompose and is clear-cut. So the way that different components are broken up is really up to the judgment of the group that did that. So please bear with us with the way that this is done. We think it's a workable solution, but it may not be the same solution that you would have come up with. And also remember that the schema is intended to aid in validating the transformation between user's model and baseline model is done correctly, and is not intended to be a universal model of everything that can appear in a building or modeled by a simulation program. So let's start with the root element of the schema so I can show you how everything is connected. So the top level element is the ASHRAE 229 element, followed by its child element, the rule set model instance. One of the children of that is building, and then building segment is under that. And under that is heating, ventilation, and air conditioning, heating system, and cooling system, which we talked about last time. And another child of heating, ventilation, and air conditioning system is FanSystem, AirEconomizer, and AirEnergyRecovery, which is what we're going to talk about today. So let's go to the schema. So this is the parent of the FanSystem data group, heating, ventilation, and air conditioning. And here's FanSystem. Just to remind you, only one FanSystem is part of each heating, ventilation, and air conditioning system. So let's start talking about the FanSystem first. So, as usual, there's a ID reporting name and notes that exists in every data group. And then the next group of inputs has to do with supply fan, basically all the fans. Supply fan, return fan, exhaust fan, and relief fan. So those are all different fans that would appear in the system. Now you'll notice that they don't refer to a single fan, but each one can refer to a list of fans. So if there's a fan array, or if there's just multiple supply fans or return fans, you can still describe that within the FanSystem data group. The next 2 data groups or data elements are the AirEnergyRecovery and AirEconomizer, and those are referencing to new 2 child data groups that we'll be talking about in a minute. And then there's a temperature control. This is an enumeration. We'll talk about that also in a few minutes. Operation during occupied and unoccupied actually use the same enumeration. Has lockout central heat during unoccupied. Basically, it's typically used when a zone has a heating coil available to it and there's no central heating that can occur. There are some requirements like that in certain rule sets, so that's either true or false. Fan control is another enumeration. Now we get to some temperatures. So the supply air temperature set point obviously is a critical thing for any fan system. The resets differential temperature is something that occurs for two different reset strategies. And here's another reset related thing. Actually, I guess a few more. Supply fan air temperature reset fraction and supply air temperature reset schedule. The reset schedule is referencing a schedule, obviously. Fan volume reset type is another enumeration related to resetting. And so is the numeric value for fan volume reset fraction. And then there's an overall operating schedule for the fan system. And then there's a way to describe the flow rates. So there's minimum outdoor and then maximum outdoor airflow rates described. You can enter the MERV filter rating, which, while not often modeled, is often a requirement in standards. There's a Boolean for whether it has a ducted return. And then finally, the last one is a enumeration for demand-controlled ventilation options. So there's a lot to take in on the fan system object. There's a lot of details, but it basically is trying to describe everything in a fan system that might have a rule set attached to it. So let's go through those enumerations next. I have to find them first. Here they are. So the first one is fan system temperature control. These are various options for control of the temperature. Most of them are basically different reset strategies on how to change the temperature depending on some other factor. But we also have constant and outdoor air reset, and scheduled, and also other if none of these cover the basis. Fan system supply fan control options. These are options for the fan control, including constant, and different ways to modulate the airflow rate, including variable speed drive, multi-speed, inlet vane, and discharge damper. Fan system operation options describes the overall type of operation that the fan has, including cycling or continuous, and keep off option would most likely be used when the operation during unoccupied data element is referencing it. And then these are some of the reset options having to do with supply fan volume reset. So there'd be constant and then reset to the design load or reset to the operating capacity. And then a few down here is demand-controlled ventilation control options. So these are where the sensor is located for the CO2, so either in the return air or in the zone. Or obviously for many systems there's no sensor at all. So that finishes up the enumerations for fan system. Next, let's go on to look at the data group for AirEconomizer. There it is. Compared to the fan system, the AirEconomizer is actually quite a simple data group. Let me scroll to the middle here. So it has a ID reporting name and notes like all data groups. And then it really only has two other inputs. One is the type of economizer, airside economizer, and then the other is a high limit shutoff temperature. Now you may be wondering where the rest of the inputs are. Rule sets, at least 90.1, and we had other rule set people involved, don't have that many actual requirements related to temperatures for AirEconomizer operation. They leave that up to the designer. But some do have limits on the high limit for the temperature shutoff. So let's look at that one enumeration, AirEconomizer options. So the first option is fixed fraction, so really not an economizer at all, but just has a damper at a certain position. And then the next four are options for how you control economizers typically, usually based on temperature, enthalpy, differential temperature, or differential enthalpy. There might be other options in this that get added in the future, but for now, those would all be covered under Other. All right, now the final data group we're covering today is AirEnergyRecovery. There we go. So it has a reporting name, notes, and ID like others. And then it has some numeric and enumerations data elements as well. So the first is the energy recovery type. That's an enumeration. And then there's an enthalpy recovery ratio. This is a change in enthalpy of outdoor air supply equal to the value of the difference between the outdoor air and entering exhaust air enthalpies at design conditions. So it's a metric for heat exchanging. And then there's enthalpy recovery ratio. Energy recovery operation is a enumeration. Energy recovery supply or temperature control is another enumeration. And then there's the two effectivenesses for heat exchangers. One is for sensible and one is for latent or moisture. So those are the effectiveness of the heat exchanger. Let's go back to those enumerations. A lot of flipping up and down looking for enumerations today. So these are the energy recovery options. They describe physically the type of heat exchanger there is. So sometimes you only have a sensible wheel, sometimes an enthalpy wheel. Sometimes it's a heat exchanger or heat pipes. So, and then there are lots of other types that would just be covered under Other. As far as the next enumeration, this has to do with energy recovery operation options. So this is what type of operation the controls have. So does it operate anytime fans are on, when there's minimum outdoor air, or some other type of scheduled or other operation? And then finally, a temperature control option. This describes whether the energy recovery runs at a certain fixed set point or whether there's a reset based on mixed air set point. So that's all today. Thanks for watching the video. As a reminder, if you have questions or comments on the schema, please just reply to everyone with your comment, and hopefully it can be resolved as part of the ballot. About a week after the video is released, you'll be getting a letter ballot from ASHRAE to vote on it. So thank you very much.